This is the starting point to understand how you can change the shape of the sea surface, how winds can change the shape of the sea surface. And this is shown here looking from the side, okay? Vertical transects looking from the side. And what you see are situations where the Ekman transports move water horizontally away from the center of these sketches, okay, or towards the center of these sketches. So just have a little look. I get the mouse going. Here's the mouse. Okay, you have a situation where the winds create Ekman transport actually moving water away from the center. Okay, this situation we call a divergence of horizontal flows. Divergence is the word for this. Okay. What it does, it actually lowers the sea surface. Okay, it lowers the sea surface, and here you get a modified shape of the sea surface, and that's what creates geostrophic flows. Okay, so you get a geostrophic flow, and this one is shown for the northern hemisphere in this situation, but you get geostrophic flows that are into the page or out of the page. Okay, the plus are out of the page, and the minus ones are into the page. Okay, in addition to that, you get an adjustment, which is called here upwelling, but the traditional word for this is Ekman suction. It's an adjustment of the density field. The isopycnal is lifted upward, but only until a steady state, a stationary field is reached. Okay, it doesn't continue this mechanism. Okay. The opposite mechanism is called Ekman pumping, and it starts with we call it a convergence of Ekman transports. So the Ekman transport, I show again let's see where the mouse is. Here you have the Ekman transport moving water towards the center, okay, in the Ekman layers, and you create a rise in the sea level. So the sea level increases, a high pressure center you actually produce. This change of the shape of the sea surface again produces geostrophic flows. Okay, they are into the page or out of the page, horizontal flows, and you also get an adjustment of the internal density field associated with a transient downwelling of isopycnals. This mechanism we call Ekman pumping. Okay, so it's important not to confuse these mechanisms, upwelling and downwelling, with the mechanism that relates to a continuous upwelling. So this is just a transient response, and this shown here in this sketch. However, what you can see in these sketches is that the internal density field in the ocean tends to be a mirror image of the shape of the sea surface. In fact, there are amplified mirror images. Okay, so the sea level anomalies are only of the order of 10-20 centimeters over vast distances. The pycnocline itself, the vertical anomalies, are hundreds of meters. Okay, so that is an important feature.